Introduction to electronics. Electronics is the branch of physics and engineering that deals with the behavior and control of electrons, or other charged particles, in various devices and systems. An atom basically consists of protons and neutrons within the nucleus and electrons moving around the nucleus. Protons have positive charge and electrons have negative charge. As a result, there is attraction between the nucleus and the electrons. The force of attraction is stronger on electrons close to the nucleus and weaker on electrons far from the nucleus. Hence, the electrons on the outermost shell experience a weak force of attraction and are therefore said to be loosely bound. Such electrons break away from the atom by the slightest disturbance and move about freely. These electrons are called free electrons or conduction electrons. In a solid body, the presence of these free electrons determine whether or not the body can conduct electricity. A solid body which have free electrons can conduct electricity, and it is called a conductor. Conductor. A conductor is a material or substance that allows the flow of electric current through it with minimal resistance. Conductors are usually made of metals like copper, silver, or aluminum, as these materials have a large number of free electrons that can easily move when an electric field is applied. Insulator. An insulator is a material that does not allow the flow of electric charge or electrical current through it easily. Insulators have a high resistance to electrical current and are used to isolate or protect electrical conductors or components from each other. Common insulators used in electronics include materials such as rubber, plastic, glass, and ceramic. Insulators are also used to coat or insulate wires and cables to prevent electrical interference or crosstalk between adjacent conductors. Because free electrons are responsible for carrying electricity through a solid, they are called charge carriers. Certain fluids conduct electricity, but they do so because of the presence of ions, cations or anions. These ions are the charge carriers. Charge carriers. Charge carriers are particles or entities that carry electric charge through a material or a medium. In most cases, the charge carriers are electrons or ions, but they can also be other types of particles, such as holes, protons, or positrons. The behavior of charge carriers is an important factor in determining the electrical properties of materials and devices. For example, the mobility of charge carriers, which refers to how easily they move through a material under an applied electric field, is a key parameter that affects the conductivity of a material. Effective temperature on conductivity of conductors. Temperature can have a significant effect on the conductivity of conductors. When a conductor is heated, the atoms in the material vibrate more vigorously. This increased motion makes it more difficult for electrons to flow through the material, leading to a decrease in conductivity. This effect is known as electrical resistance, and it is caused by the collisions between electrons and the vibrating atoms in the material. Conversely, if the temperature of a conductor is decreased, the atoms will vibrate less, and the conductivity of the material will increase. This is why some materials, such as superconductors, can conduct electricity with zero resistance at very low temperatures. In practical applications, the effect of temperature on conductivity must be considered to ensure that conductors are able to perform their intended function. For example, electrical wiring must be designed to handle the expected amount of current flow at the expected temperature range to prevent overheating or underperformance. Effect of temperature on conductivity of insulators. As the temperature of an insulator increases, the atoms in the material gain more energy and begin to move more rapidly. This can cause the electrons in the material to become more mobile, allowing them to move more freely and potentially leading to an increase in conductivity. This effect is known as thermally activated conduction, and can be observed in some types of insulators. However, this increase in conductivity due to temperature is typically very small in insulators compared to conductors. Insulators still remain poor conductors of electricity, even at high temperatures. Therefore, in practical applications, the effect of temperature on the conductivity of insulators must also be taken into account to ensure that they function correctly and safely. Insulation materials in electrical systems, for example, must be able to maintain their insulating properties even at high temperatures to prevent the risk of electrical fires or other hazards. Semiconductor. A semiconductor is a material that has an electrical conductivity that is between that of a conductor and an insulator. A semiconductor can conduct electricity because of the presence of charge carriers, which are free electrons and holes. Semiconductors are used extensively in the electronics industry as they can be used to create a wide range of electronic devices, including diodes, transistors, and integrated circuits. The most common semiconductor material is silicon, which is widely used in the production of electronic components. Other materials, such as germanium, gallium arsenide, and silicon carbide, are also used as semiconductors in various applications. Factors that control the conductivity of a semiconductor. The conductivity of a semiconductor can be controlled by a number of factors, including 1. Doping. Doping is the process of intentionally adding impurities to a semiconductor material. This changes the number of free electrons, n-type, or holes, p-type, in the material, which affects its conductivity. 2. Temperature. The conductivity of a semiconductor material is also affected by temperature. As the temperature increases, the number of free electrons in the material also increases, leading to a higher conductivity. 3. Light. Certain semiconductor materials are photoconductive, which means that their conductivity changes when they are exposed to light. This property is used in the construction of light-sensitive devices such as photodiodes and solar cells. 4. Electric field. An electric field applied to a semiconductor material can affect its conductivity. This property is used in the construction of devices such as field effect transistors. These factors can be manipulated in the production of semiconductor devices to control their electrical properties and optimize their performance for specific applications.